Next up, we have Edmund Edgar, founder of Reality ETH, who will be presenting on subjectivocratic oracles and forking ledgers. Welcome, Edmund.
Okay, I'm kind of losing my voice here. I don't know if it's going to make it all the way through. You may have to imagine the second half, but I'll do what I can. So yeah, if we haven't met, I'm Edmund Edgar. I created the first smart contract oracle, Reality Keys, way back when. Now I maintain reality.eth. I'm going to be talking about the new thing we're building. But before that, I want to do kind of a lot of background, a lot of fundamentals. So I want to start just a really fundamental level. How do we secure stuff in crypto economics, right? How do we secure stuff on blockchains? When I say secure stuff, what we're doing is we want to make some rules that are going to get applied by the system, the rules that kind of the user expects. So if it's like a layer one system like Bitcoin or Ethereum, then you basically want to order transactions. You maybe want to do some execution rules. If it's an application that we're building, if it's a Bitcoin price oracle, it's got to give you the correct Bitcoin price. If it's a DAO that's supposed to fund putting flowers everywhere, then it's got to actually put flowers everywhere, and it's insecure if you can make it use its money for some other purpose. Okay, so let's look at kind of Bitcoin and Ethereum, the base layers. How are they done? One of the mechanisms is sort of voting and hash power voting and stuff like that. That's not used very much at all in base layers, and there's a reason for that, which is that it's generally horribly insecure. Voting is susceptible to bribery. In theory, you can bribe people really cheaply, even at a fraction of the value of the thing that you're stealing. And also, you often have misalignment between the people who are doing the voting and the people who are the actual target users of the system. So that's used in Ethereum for things like the block gas limit, just the capacity management of the system. It's used a little bit in Bitcoin for kind of one stage of whether you accept an upgrade, as they do soft forks, which is sort of minor voting. But it's not used very much because it's bad. What's much more robust is what we call shelling games. So what we're trying to do is everybody is trying to follow some rules that everybody else is also trying to follow. And you get rewarded if you do the same thing that everybody else is doing, and you get punished if you do something that other people aren't doing. So the classic example is in Bitcoin, everybody's trying to build on the longest chain of blocks. And if I've mined a block and I build on a shorter chain, then that's not going to get included in the chain because the next person is also trying to build on the longest chain, so they're going to ignore it. So that's going to cost me money. But this has the famous 51% attack problem, which is that if you get 51% of participants who are malicious, then they can start to apply their own rules. So the one we're worried about in Ethereum recently is what happens if 51% of stakers decide that they're going to censor blocks with Tornado Cash transactions in them. And that could be pretty bad. But there's a final layer of security which underlines all these systems. And some people, especially kind of in the Bitcoin tribes, like to pretend this isn't there, but it is. And it's part of it, and it's what really underpins the security of base layers. And that's what Vitalik calls subjectivocracy. And I'll give you a link at the end to read Vitalik's piece on subjectivocracy, which is really good. If we look at this case where, for example, stakers of Ethereum might try to censor transactions in Ethereum, or to censor blocks containing those transactions, what we could do is we could simply follow a chain in which they were no longer stakers, right? We can do what we call social slashing, delete their stake. We subjectively say, this is the chain that we want to follow. We don't care what your rules say. We're going to follow this chain. If you had to do this all the time, it wouldn't work. There'd be no point in having a blockchain because it would be chaos trying to coordinate. But you can do it occasionally, and it works. And it's also how Ethereum does governance upgrades, right? When you do an Ethereum upgrade, somebody publishes the software and it has new rules and you can follow it. And if you think it's bad, you don't have to do the upgrade. And we've had contentious cases, like with the DAO bailout fork, where we ended up with different coins. We ended up with Ethereum and Ethereum Classic. So that is really robust as a governance as a mechanism for enforcing rules, because it doesn't rely on counting something, right? It doesn't rely on having the majority of the stake or the majority of the hash power or the majority of anything. It just relies on the users following what they want to follow, okay? So that's base layers, that's your Ethereums, your Bitcoins, but most of us aren't building base layers, we're mostly building applications. And there it looks something more like this. We have lots and lots of voting, especially DAOs overwhelmingly using coin voting, which is terrible. We have a few very well-designed systems, things like, Kleros is one that use shelling games. They're quite hard to build, but they do sometimes exist. And we have hardly any subjectivocracy. And that puts us in a bit of a pickle, because it's really hard to build secure systems without that backstop of subjectivocracy. You may not have to go as far as the fork. Like usually we don't have these kind of things that have caused us to need to do social slashing in Ethereum. But the fact that we can is what makes Ethereum secure. And we don't have that in the application space. And that means that you've got this economic security bound that Clement from Kleros was talking about yesterday, where you've got stuff managed by a token. The token has a certain value. If it's securing more than the value of the token, then it's profitable to whether by bribery or buying half the tokens or by whatever method, to attack the system and to break it and to steal it. And this is kind of hitting us like throughout. It's everywhere in the stuff we're building right now. So we've got a bunch of DAOs, with token voting that's horribly insecure. We've got Oracle systems that just can't escape this, this fundamental limit. And it's really bad to have this security bound, because there's no way to know in the future how much you're going to be securing or what your token value is going to be. So especially if you're putting something in a long-term contract, you need to know that the system's going to be secure when it settles. But there's no way to know that. And it's going to kind of tend to get worse over time. So if you think about the valuations of a lot of these systems, the valuations of systems that we have now are nearly all based on their revenue thinking about the future, right? They're not based on the revenue and the usage that they're getting now. And the same happens with startups. Like an early stage startup will have quite a low amount of revenue compared to its valuation. But then when that future comes, we're going to be in a situation where we've got to carry all of that usage, and all that amount that you can steal is all going to be there, and the token value is only going to represent the revenue that you can actually extract from the protocol. So it's a pretty serious situation we're in, and I think it's kind of ridiculous that we've kind of got ourselves into this situation where we have this mechanism, the subjectivocratic mechanism, that works on the base layer, but it doesn't work for our applications. And the result is that we've got much less security than we could have for applications, and it's much harder to build applications than it should be. So we shouldn't have this problem, because the blockchain isn't real, right? The blockchain is something we made up. It's our model of reality. So we shouldn't be putting ourselves in this corner where we won't allow our blockchain to model reality correctly, or where we could all see that something's gone horribly wrong. You've got a lot of people using a system with a shelling game or something that's been attacked. It's a big public attack. We can all say it's happened, but there's nothing we can do about it, because we're building on a layer that doesn't have subjectivocracy. Now, I said earlier that you hardly ever see subjectivocracy in the application layer. You do see a little bit. One thing you can do, they did this with ENS, is you can deploy a contract, and then when you want to change it, you can deploy a new contract, and people can use the new contract. So we can do that with oracles. You could, if you had an attack on your shelling game system, you could deploy a new version of the oracle, and maybe you could save some of your token holders. But the people who are calling that oracle are still screwed, right? So the way we want to build things is we want to have a lot of separate contracts that all talk to each other. So it's no good to just fork one of the contracts, because all the contracts that it talks to also need to know that they need to talk to the new thing. So if we're going to get subjectivocracy at the level of the application, we can't do it at the level of a single contract. We've got to take an entire ecosystem and put it on a chain that we can fork, right? Now, that may sound like kind of a bold proposition that we're going to, we've got all these deployed contracts already on Ethereum, and we're going to start putting them on a new ledger. But that's the Ethereum scaling roadmap, right? So the old Ethereum was we would have one layer with lots of contracts talking to each other on that layer. The new Ethereum looks more like this. We've got a couple of different rollups. Each rollup contract lives on layer 1. That has a state root, which contains kind of a commitment to all of the data on the layer 2 system, which is where the contracts live. So we can do something like that. Instead of a regular rollup, we're going to make a forkable rollup. It's going to look just the same as a normal rollup until you pay it a lot of money. And when you pay it an ungodly amount of money, it's going to fork. We're going to have two versions of the entire ledger, two versions of the entire layer 2 ledger. On one of them, we've got a commitment to one decision, and on another, we've got a commitment to another decision. So let me take you through kind of an actual example. I'm going to do this with Reality ETH, which I maintain, but this part could be done with another oracle, but using the same kind of fallback dispute resolution mechanism. So let's imagine that I've insured my goat against getting sick, so I can pay the vet bills. When we come to settle that, I'm going to try and make a claim. The insurance contract's going to send a message to reality.eth. And then somebody can answer the question. When they answer it, they're going to put in a bond. The way Reality ETH works, somebody can then come in and challenge that. So it's similar to the UMA thing you just heard, except it keeps going in our case with Reality ETH. So then Alice can come in and switch it back, and we can go backwards and forwards. It has to double every time, so it escalates and escalates and escalates. And then you finally get to a point where somebody pays a fixed fee to an arbitration contract. And the most common one that people use right now for this is Kleros, which you may have heard about yesterday, which is this kind of internet court system, dispute resolution system. So that's all good, but OK, what happens if Kleros is attacked? Because Kleros has an economic security bound. That's where the new part comes in. What we can do is, this time we're going to dispute the arbitrator. We're going to say they got hacked. People can start putting in bonds. If there's only one bond, maybe we finish right away, but that could keep going. People can keep escalating. People putting more and more money in the game. And you can, by the way, you can change these participants. It doesn't have to be the same person all the time. So if the early participants ran out of money, maybe somebody doesn't care about the goat and they don't care that much about Kleros, but they can see that somebody is making a false claim, so they can make some money by rejecting it and putting up a higher bond. So we keep going until somebody pays a large amount of money to do arbitration by fork. At that point, we're going to split the system into two, and there we go, OK? So what that's done is it's given us it's kind of freed us from this economic security bound. We can choose which ledger we're going to use. Anyone can choose which ledger they want to use. So there's no amount of voting, no amount of money that can allow a malicious person to take over this system. It's a layer 2 with a layer 0, right? It's socially people using the system that they want to use, and there's no amount of money that you can use to bribe it or twist it. We also allow you, since it's a layer 2, it can also talk to the layer 1. So it's possible to bridge assets from the layer 1 to the layer 2. You can lock ETH up in layer 1 and then move them across to layer 2. But when you do that, those assets are going to tend to be subject to the same kind of economic bond security bond, because they're at some point going to have to decide somehow which of these fork chains they're going to honor. So it gives you this kind of infinite security bound for assets you issue on the ledger. OK, so that's what we're building right now. We're prototyping this on ZK EVM, but I also really like ZK Sync, and I'm kind of Tyco curious. Anyone else, please, show me your layer 2 system. I'll put up this link. Has a little bit more design detail. You can read a little bit more about what we're doing to how the bridging of assets works. And there's also a link to an ETH research post by Alex, who's here. about how stablecoins can be built to handle forking better if it happens. So this is obviously relevant to us if you want to build a stablecoin on this ledger, but also relevant to stablecoins that you may build on Ethereum, because Ethereum may fork. Okay, so I hope that's interesting, and see if anyone's got any questions.